Hey grade 10s, I'm going to be going through a test paper on functions and trig graphs, working through a question paper and doing the answers for you as I go. I encourage you to possibly pause the video, try the question yourself, and then push play to see if you got the answers correct. Okay, so let's get in it straight away. We're starting off early days with some function notation kind of questions, and it starts off with 1.1. that says the following. Given fx is negative 2x plus 4, gx a half x squared minus 8, and hx is 3 to the power x, use the functions above and answer the following. Now before we get into the question, let's just remind ourselves that that first function is the function of a straight line, y equals mx plus c. The second function is a parabola because it's in ax squared plus q format. And the third function is the function of an exponential, which is in ab to the power x plus q. Okay, so 1.1.1 asks us to work out f of 3. So function notation means that wherever you see an x, you're going to replace it with the value of 3. So f of 3 therefore means negative 2 times 3 plus 4, based off the straight lines equation over there. Meaning that f of 3 can boil down to be negative 2. 1.1.2 says h of 0. Same thing, you're going to sub 0 in wherever you see an x, meaning 3 to the power 0, making h of 0 equal to, anything to the power 0 is 1. 1.1.3 is a little bit different. It says solve for x if gx is equal to 0. So in this case, you're going to make gx equal to 0 and solve for x. So there's gx. So we're going to say 0 is equal to a half x squared minus 8. So using our knowledge of equations, if we have x squared, it means we're going to have two answers. So one thing we could do is take out a half as an HCF. So x squared minus 16 would be left in the brackets. The half could disappear because if you had to divide a half on the other side, 0 divided by a half would be 0. So 0 is equal to our bracket. Our bracket can be factorized using difference of two squares, x plus 4 and x minus 4, making x equal to either negative 4 or x equal to 4. Happy? So 1.1.3 worth 4 marks. Hopefully you got the majority of those marks. 1.1.4 asks you to work out negative 4 of g1 minus f of negative 1 plus h of 3. So moving on to this one, it's a case of subbing in. So negative 4 times g of 1 would mean negative 4 brackets. Now we sub 1 into the gx equation over there. In other words, a half times 1 squared minus 8. Happy? You can see it there. A half times 1 squared minus 8. The question goes on to say minus f of negative 1. In other words, minus f of negative 1. Our f graph was negative 2x plus 4. Meaning we're going to say minus, because we are subtracting here, f of negative 1, negative 2 of negative 1 plus 4. The last part of the question asks us to also add h of 3. In other words, we're going to sub 3 into the x up top there. So we're going to say plus 3 to the power 3. Happy? Now it's just a case of finding the values out here. We can use our calculator for this, typing the whole thing into our calculator even, or we can do it bit by bit. Negative 4 if we want to leave it for now. A half times 1 would be a half, and a half minus 8 would be negative 7,5. We are going to subtract. What does this bracket give us? Negative 2 times negative 1 is positive 2, and 2 plus another 4 is 6. And then we're going to add 3 cubed, meaning add 27. If we go and use our calculator at this stage to type in our values, we could see negative 4 times negative 7.5 minus a 6 plus a 27, and we're going to get an answer of 51. So our final answer, 51. Moving on to 1.1.5, it asks whether h, the function h, is decreasing. Is the statement true or false, and give a valid reason for your answer. Just to remind ourselves, hx is 3 to the power x. Just in the nutshell here, if you had to visualize what hx looks like, we know it's an exponential function because the base is a base of 3. Because the base lies between 0 and 1, in other words, you would see that your graph would be an increasing function, much like that. So, for them to say that it's a decreasing function would make the statement false. Okay? And the reason being would be that the base of 3 is bigger than 1, making it an increasing function like that. You could add into your answer that it's an increasing function, not a decreasing one. Okay, 1.1.6 asks you to give the range of function g. Just reminding each other here, g was a parabola, and it's a happy parabola that's moved down by 8. So without drawing it in any huge detail, a happy parabola moved down by 8 would have looked something like this. There we go, happy parabola moved down by 8. In other words, the turning point would be down at 0 and -8. The turning point is critical for our range. So our range in this case would be y values that are bigger than or equal to -8, and y is an element of real. Another way of presenting your answer would be to say that y is an element of square bracket -8 up to infinity and curly bracket like that. Happy. So there are your opening, let's see how many marks. The opening 3, 4, 5, 9, 12 marks of your question 1, and hopefully you've got off to a good start in this test paper. We move on to question 1.2. It asks us, or tells us, given tx is -x squared plus 9, so let's just remind ourselves, what type of function would that be? It would be a parabola. It would be a sad parabola because the coefficient is -1 and it's moved up by 9. It tells you that it's got the points a, -1 and m, and b, which is n and -7, and they tell you that n is greater than 0. In other words, that n needs to be a positive value. They lie on the graph. Part 1 says, give the coordinates of the y-intercept of this function. Remember, the y-intercept has got to do with the q value over there. So because it's a sad graph, having moved up by 9, it would mean that the coordinate of the y-intercept would be what? It would move up by 9, hence it's going to be 0 for x, and it's moved up to 9 as the y-intercept. Okay, moving on to the second question. Calculate what the coordinates of the x-intercepts are. Right, to find the x-intercepts, we let y equal 0. Remember, tx is a notation for y, so we're going to say 0 is equal to -x squared plus 9. Let's do that. 0 is equal to -x squared plus 9. So we've got two ways to tackle this answer. We could either divide everything by -1 to change the signs, giving us x squared minus 9. Using difference of two squares, we know there are going to be two answers, x plus 3 and x minus 3, making x equal to either -3 or x equal to +3. Just bearing in mind though, they've asked for the x coordinates. So at the moment, we haven't given our answer in coordinate fashion. So we'd have to say -3 and 0 or 3 and 0. The other way you could do a question like this is to say, let's take the -x squared to the left, making it x squared equals 9. X squared indicates two answers. So if I square root x squared, I'd get to x, and I would get two answers by square rooting 9. I'd get the positive or the negative option, making x equal to either 3 or x equal to -3, ultimately still giving out two coordinate answers. Happy. They move on to 1.2.2, saying calculate the coordinates, or part 3, sorry, calculate the equation of the axis of symmetry for t. So remember, when we deal with parabolas in grade 10, our axis of symmetry is always the x value of the turning point, meaning x equals 0. If I had to draw a rough picture of any sort of parabola, the axis of symmetry would refer to the y-axis, where it would fold nicely on top of itself. And the equation of the y-axis is x equal to 0. That goes for all grade 10 parabolas. 1.2.4 then asks us to determine the values of m and n when n is bigger than 0. So, if we look at m's value first, m is the y-coordinate when x is -1. So, we are basically just going to sub -1 into our parabola's equation. So, t of -1 would be equal to negative of -1 squared plus 9, making t of -1 equal to -1 all squared would be 1, and negative times the 1 is -1 plus 9 would give us an answer of 8. In other words, m ends up being 8. Lastly, they ask us to work out n's value. N is the unknown x value when the y value is -7. So we make y equal to -7 and sub n in place of x. So here we go. -7 is equal to -x squared plus 9. So we need to solve for x, or maybe I should write it rather as -n squared plus 9, because n is my value for x. So solving for n, we would first of all possibly subtract 9 on this side. -16 is equal to -n squared. We could drop the negatives, making 16 equal to n squared. We now know that n would be the root of 16, giving us either the positive or the negative root of 16, making n equal to 4 or n equal to -4. However, the question has specified that n needs to be bigger than 0. So of these two answers, you're going to reject -4 and take n of 4 as your final answer there. Ultimately, you've got now coordinates. A is now no longer -1 and m, it's -1 and 8. And you know that B is no longer n and -7, it's 4 and -7. All good. We go to 1.2.5, who asks us to sketch the graph on the given Cartesian plane. We're going to draw one for ourselves, and we're going to have to indicate and label the intercept points, turning points, A and B, and the axis of symmetry. Okay, so we know that the equation of this graph, as we noticed earlier, was y is equal to -x squared plus 9. So this is the graph we need to sketch now. So we can draw a rough, quick little Cartesian plane. We've got the x horizontal and the y vertical axis. We know that the plus 9 means that the turning point has shifted up to 9. And earlier on we worked it out to be 0 and 9. We know it's a sad graph, so the parabola is going to go down like that. And earlier on in the question, we worked out that the x-intercept, were 3 and 0 and -3 and 0. The question also asked us to label the asymptote, or the axis of symmetry rather, which is the y-axis, and his equation is x equal 0. And the 2 points that this graph will go through is -1 and 8. So -1 and 8 would be where A is over there roughly. And B is 4 and 7. 4 is past 3. And -7, means 4 over there. And -7 somewhere in this vicinity over there. Obviously, if you have a question like this in a test, you most likely will be given a Cartesian plane to work off from to make it a bit clearer, but that is good enough for us. Right, so that's 1.2.5, and it concludes a 27 question 1 question, and hopefully you've got the majority of those marks. Okay, we move on to question 2 now, where we'll see a bit more functions being tested. Here we go. Question 2. fx is equal to negative b to the power x plus q, and gx is k over x plus p. Before we dive in any further, we should know that fx shows us an exponential graph, while gx speaks about a hyperbola. We know that because of the formats those two functions are in. It goes on to tell you that the points a, 0 and 3, let's go look at it. There's a, 0 and 3. B is 1 and 2. And d, x and negative 2, there's d over there, x and negative 2, are points on the function f. So, before we dive in any further, let's just make sure we can spot the two graphs. So, we've got this side of the hyperbola over there, and this side of the hyperbola over there. There's our hyperbola given in the function above. In terms of the exponential, our exponential equation is the fx graph, and it's given by that graph over there. Okay, so now we're ready to look at the first part of the required, which says, give a valid reason why k is bigger than 0. Okay, so k we know is the value on the hyperbola that tells us which quadrants the hyperbola's arcs would be drawn. So the fact that the hyperbola is drawn in the adjusted quadrants 1 and 3 tells us that k would have to be bigger than 1, or bigger than 0, sorry, because we have our hyperbola, and this is our answer. Our hyperbola is in quadrant 1 and quadrant 3, telling us that k would have to be a positive value. If it was a negative value, our hyperbola would have been in quadrants 2 and quadrants 4. Moving to question 2.1.2. Give the equation, and they've made that word in bold, of the horizontal asymptote of the function g. So g is our hyperbola, and the horizontal asymptote is the dotted line that the hyperbola cannot cross. Remember that all horizontal lines are in the format y equals constant. So the constant value here is given by the negative 2 as part of d's coordinate. So our answer is y is equal to negative 2, which is the equation of the horizontal asymptote of our yellow g hyperbola. Moving to number 3. Use the information in the diagram to show by clear calculation that b is 2 and q is 4. So obviously looking at our exponential graph here, we have to somehow show that b, our base in our exponential, ends up being 2, and q, which refers to the vertical shift up or down, would be 4. Okay, so the way we do it is we look at the coordinates where our pink exponential graph is going through. So if we sub in some coordinates, we hopefully will see the values of b and q emerge. So writing out our function as it stands, it's negative b to the power x plus q. Now the coordinates we've got to sub in are either a, which remember is 0 and 3, or b, which is 1 and 2. And I'm going to say, let's sub in a, which is 0 and 3 first. So by subbing in a, we'll have 3 is equal to negative b to the power 0 plus q. Negative of b to the 0, remember anything to the power 0 would be 1, so negative of 1 plus q. Ultimately, q would be equal to, if you add the 1 over, 4. Great, so we've got what they wanted, that q is 4. Now we can say fx is now equal to negative b to the x plus 4, because we know q is 4. Now we have to work out the value of b. We've got another point that we could plot or sub in, and that's b. So we're going to sub in b, which is 1 and 2. So 2 is equal to negative b to the 1 plus 4. All good? Solving for b, we could subtract 4. 2 minus 4 is negative 2 equals our negative b, ultimately proving that b must equal 2. So our final answer, or our final version of our exponential, is negative of 2 to the x plus 4. And we've got another 4 marks in the bag. 2.1.3 says the following. Use the information in the diagram. Okay, we just did number 3. Number 4, give the range for G. The range, remember, refers to the Y values in a picture. So, the Y values of G, being our yellow graph, would be what? Everything is going to be going up forever. It's going to be going down forever. However, there is a Y value that the yellow hyperbola will never be able to touch. And that's the asymptote. So our answer cannot include -2. So ultimately, we'd be able to say that Y is an element of real. It can be all real numbers. However, Y cannot equal -2. All good? We've got hopefully that one correct. 2.1.5, if it is given that C is the position 2 and 0, so let's go add that to our picture here. C is 2 and 0. It then goes on to say, for which values of x will fx equal our gx? In other words, the points of intersection where the yellow hyperbola and the pink exponential would equal each other. So x values are what we are after. At B and at C, the two graphs are equal to each other. So those are the points that we are after. In other words, we're going to be able to say that x is equal to 1, being the B x value, or x is equal to 2, being C's x value. Happy? And those are the two x values where the graphs are equal to each other. The second part of this question says, where is gx bigger than or equal to 0? So, gx is our yellow graph. Where would it be bigger than or equal to 0? In other words, where is the g graph above the x-axis? This area here, it's negative because it's below the x-axis. This area here, it's also negative because it's below the x-axis. So basically, it's everything to the left of C and to the right of the y-axis. So it's just this little corridor of our hyperbola over there. But the question asks for x values, so it would be everything in that little region of the x-axis, meaning from 0 up to 2. Please also notice that we are allowed to equal 0. Okay, so there's a little line over there. However, when we go to our answer, we are between 0 and 2. We can equal 2, however, we cannot put a line under the zeros inequality because the hyperbola will never equal 0 based on it being an asymptote of our hyperbola. Happy? So between 0 and 2, inclusive of 2, but not including 0, our hyperbola would have been greater than or equal to 0. Going to 2.1.6, it says determine the length of AE. Right, so let's look at our graph. AE is our distance from A down to E. E's coordinate would have been an x of 0 and a y of -2 because it's lying on this horizontal asymptote. So the distance A down to E would be an examination of their y values. From 3 down to -2 would be a change of how many units? It would be a change of 5 units. Therefore, 2.1.6 AE by observation would be equal to 5. You could write 5 units if you'd like, and there we have the value of AE. Happy? So a few more marks here for functions. Hopefully not too bad and you're feeling okay. Right, we move to 2.2. 2.2 obviously has got a trig graph and hopefully not too intimidating. It says in the diagram below, you are given the graph of fx equals negative cos x, okay, where x is an element between 0 and 360. So the thing to realize is that that negative is different from our original cos graph. So, first question 2.2.1 says give the amplitude of f. Remember, the amplitude measures half the distance between the maximum and the minimum. So there's the maximum it reaches. There are the minimums the graph reaches. So from positive 1 to negative 1 is a change of 2. So the amplitude would be half of 2. So the amplitude of f would equal 1. Please note, the amplitude is also given by the coefficient to the graph. However, it would be incorrect to say negative 1 as your amplitude. Your amplitude is a positive 1. Right, 2.2.2 asks us to give the range of this function. The range, once again, refers to the y values from negative 1 up to 1 are the values that the range is reaching. Negative 1 up to 1, y in the middle of our inequality, and we can put our inequalities with equals lines because it can get to negative 1 and it can get to positive 1. Happy? 2.2.3 then says, for which values of x will the function of f decrease? Okay, so reading left to right here, you'll see that your graph is climbing uphill, and then at this turning point, it then decreases down. So for which x values will this function decrease? Well, it decreases over there. So everything from 180 up to 360 will the graph decrease. So we write it as 180 up to 360, and there we go. It's not a range question, it's a domain question. So it's vital that x is mentioned as our variable. 2.1 or 2.2.4 then says, use a given grid, and we're going to just draw one for ourselves, to sketch the function of hx, which is 2 sine x, between 0 and 360. So very quickly, we would be able to most likely be given a Cartesian plane for questions like this, but we can label it very quickly for ourselves. Right, if we go 45 and we're going to label it every 45 degrees, we're going to get our Cartesian plane ready for our points that we are going to plot. Okay, 315 and a little bit further, 360. Okay, so the graph, let's remind ourselves we are drawing, is 2 sine x. hx equals 2 sine x. So it means that our graph is going to reach as high as 2 and as low as negative 2. Just to remind you, you do have the facility on your calculator. Mode, you'd push there and choose table. You can type in your equation, which is 2 sine alpha x, close brackets, equals. Your start refers to the x-axis where you want to start with, subbing in. So 0 equals up to 360. And if our Cartesian plane has a step of every 45, we would use a step of 45. Our calculator thinks a little bit and then gives us some values. So using these values, we can plot our points. So at 0, we'd be at 0. At 45, we are 1, 4-ish. So 1, 4-ish looks to be roughly over there. At 90, we are up at 2 over there. At 135, we can see we are at 1, 4-ish once again, so we can plot our dot there. At 180, we are at 0. At 225, we are at negative 1, 4-ish. There's negative 1, there's negative 2, negative 1, 4-ish, let's say over there. At 225, our calculator, we just did that one. At 270, we are at negative 2. Okay, I'll put the dot in the wrong place there. And then at 270, our calculator says we are at negative 2. So we can go down to negative 2 for 270. You're all understanding. At 315, we are back to negative 1, 4-ish over there. And at 360, we are at 0. So if you use the calculator method, it's easy to plot the points. And now we can just join our dots and connect like so. And we've got our pretty hx graph, which is 2 sine x. Just remember, our original graph of sine x would have looked similar. However, at 90, he would have only reached 1. At 270, he would have only reached negative 1. So the difference between the original sine graph and this graph we are drawing is that it's reaching a higher and a lower point than our original sine x graph would have reached. Okay, so we've labeled some nice intercepts here. The question did say plot also and show the turning points and the intercepts with the axes. So the turning points as coordinates would have been 90 and 2 and 270 and -2. Happy? The last question, 2.2.5 over here, says given that tx, which is hx minus 1, what are the coordinates of the maximum and minimum points of t? So t is our given h graph moved down by 1. So if you had to look at the graph we just drew, if we had to visualize it moving down by 1, it means that our maximum point is now 90 and no longer 2, but at 1. And it means that our minimum point is no longer 270 and -2, it's 270 and -3. Happy? So we've now identified our maximum and minimum points by looking at how h has moved down. Great. So that was a 50-mark test covering functions and trig graphs. I hope you feel good about these sections for your possible assessments and exams coming up. All the best for grade 10. Work hard and the rewards will come.